will start in a couple of minutes. All right, 8 o'clock. We'll be in section 5.2 again, properties of exponents. We'll go over the properties that we already covered real quick. Let A and B be non-zero real numbers, and let M and N be integers. The product rule, A to the M times A to the N can be simplified to A to the M plus N, so you add the exponents. The quotient rule, if you're dividing A to the M by A to the N, you can simplify that to A to the M minus N. I'll just note that this is also equal to 1 over A to the N minus M. You might want to do it this way if N minus M is positive and M minus N is negative. But this follows from the negative exponent rule. If you have A to the negative N, that's equal to 1 over A to the positive N. And then also 1 over A to the negative N equals A to the positive N. Then for a quotient, like A over B raised to the negative N, you can write that as B over A to the positive N. And then that can be expressed as B to the N over A to the N. Then the zero exponent, if the base number is non-zero and the exponent is 0, that equals 1. Power property, if you have A raised to the power M, and if that is raised to the power N, you can simplify that by multiplying the exponents and write A to the M times N. Then a product to a power, inside the parentheses we have A times B, and that product is raised to the exponent m, then you can write that as a to the m times b to the m. And then finally, a quotient to a power. We already applied this once today, but if you have a over b raised to the power m, you can write it as a to the m divided by b to the m. Okay, we'll continue practicing simplifying various expressions. Hey, we did these first two on Friday, but we'll do them again. Here we have m times n to the negative 3 times m to the negative 5 times n to the negative 2. You can simplify fairly directly if you want, or you can rearrange the terms. Since we're just multiplying 4 terms, we can rearrange them. Remember that m is m to the first. So m to the first times m to the negative 5 times n to the negative 3 times n to the negative 2. Then m to the first times m to the negative 5 is m to the 1 plus negative 5, which is negative 4. And then n to the negative 3 times n to the negative 2 is n to the negative 3 plus negative 2, which is negative 5. In the end, we don't want any negative exponents. So remember that m to the negative 4 is 1 over m to the positive 4. And we multiply that by 1 over n to the positive 5. And then multiply those together, we get 1 over m to the 4th times n to the 5th. Since the variable bases are different, we cannot simplify any more than that. That's as far as we can go. Yeah, the next example, we're just multiplying factors again. Negative 5 times a to the negative 2 times b to the negative 8 times 8 times a to the 7th times b to the 6th. So if you want to rearrange the factors, you can. We can write the numerical factors next to each other. Negative 5 times 8. And then a to the negative 2 times a to the 7th. And then times b to the negative 8 times b to the 6th. Negative 5 times 8 is negative 40. A to the negative 2 times a to the 7th is a to the negative 2 plus 7, or a to the 5th. And then b to the negative 8 times b to the 6th is b to the negative 2, because negative 8 plus 6 is negative 2. And then the last step, negative 40 times a to the 5th is in the numerator, and in the denominator is b to the positive 2. So just note the coefficient is negative 40. That's the numerical factor that we're multiplying by a to the 5th. So it stays where it is. It's only when you have a negative exponent, like b to the negative 2, when the exponent is negative, you move it across the division bar and make the exponent positive. Okay, so some of these will get more and more complicated. We'll have some fairly simple ones along the way too. Okay, this one we have a quotient. That's the rational expression inside the parentheses that is raised to the exponent negative 2. So we have options. We can focus on simplifying what's inside the parentheses first, and then afterwards deal with the outer exponent of -2. Or if you would rather, we can deal with the outer exponent of -2 first, and then simplify the rational expression. So I think what I'm going to do is I'm going to simplify what's inside the parentheses first, and then afterwards we'll deal with the outer exponent that's -2. So first begin with the numerical coefficients. 4 divided by 7, that cannot be simplified any further than it is. J to the 7th divided by j to the 3rd. That's j to the 4th in the numerator, because 7 minus 3 is 4. And then k to the 4th divided by k to the 9th. That's k to the 5th in the denominator. So we can look at that by itself if it's necessary. K to the 4th divided by k to the 9th. So when we were reviewing the properties, we saw two ways to simplify this. One is k to the 4 minus 9 over 1, which is k to the -5. But then k to the -5 over 1 is 1 over k to the 5th. So that's one way to get to the simplified result. The other way, if you have k to the 4th over k to the 9th, is to write it as 1 over k to the 9 minus 4, or 1 over k to the 5th. So no matter how we go about it, we should end up with the same result. And over here, that just means k to the 5th is in the denominator. Okay, so now we can deal with the outer exponent. We have a fraction raised to the -2. So we reciprocate the fraction. So 7k to the 5th will be in the numerator. 4 times j to the 4th will be in the denominator. And we change the outer exponent to +2. Okay, so now we can expand further. So in the numerator, think of 7 times k to the 5th. Think of that as 7 to the 1st times k to the 5th. And in the denominator, we have 4 to the 1st times j to the 4th. And when we apply this outer exponent 2, we're going to multiply this exponent 2 times each of those 4 exponents. So we get 7 to the 2 times 1, or 7 to the 2nd, times k to the 2 times 5, or k to the 10th. And in the denominator, we get 4 to the 2 times 1, or 4 to the 2nd, times j to the 2 times 4, or j to the 8th. And there's just one step left. We can expand or simplify 7 to the 2nd. So we get 49 times k to the 10th in the numerator. In the denominator, 4 to the 2nd is 16. So we get 16 times j to the 8th. And that is as far as we can simplify that. So just a reminder, when you have a simplified rational expression, it's a rational expression because it's a ratio of polynomials. Each variable appears at most one time. So k appears once. the exponents on the variables have to be positive, and then the coefficient fraction, 49/16, has to be in lowest terms, which that is. Okay, the next one is more complicated because we have a rational expression raised to a negative exponent, and we're multiplying that by another rational expression raised to the exponent +2. So what we want to do is we want to simplify each of the rational exponents raised to an exponent first. So we'll simplify those two on the outside, and then afterwards we'll multiply them together. Okay, so on the left, I'll simplify what's on the inside of the parentheses first, and then afterwards we'll apply the outer exponent -3. And the same with this expression on the right. We'll simplify what's inside the parentheses first, and then apply the outer exponent too. Okay, so inside this set of parentheses, 3 divided by 2, that doesn't simplify any further. Then when we focus on the variable r, we have r to the -5 divided by r to the 3rd. So that's going to become r to the 8th in the denominator. Then when we focus on the variable t, we have t to the 6th divided by t to the 13th. So this becomes t to the +7 in the denominator. Okay, now let's work on the other set of parentheses. Inside we have 5 divided by 8, so that stays the same, 5 divided by 8. R to the 2nd divided by r is r, which means r to the 1st, which is in the numerator. And then t to the 3rd divided by t to the 2nd is t in the numerator, t to the 1st in the numerator. Okay, now going back to the expression on the left, we'll deal with this outer exponent -3. That means we're going to write the reciprocal of the fraction. So we're going to have 2 times r to the 8th times t to the 7th divided by 3. And we change the outer exponent to +3. For this expression on the right, we can apply the outer exponent too. So in the numerator, we're going to get 5 to the 2nd. Remember what we're doing. We're multiplying the outer exponent times each of the exponents of the factors in the numerator and denominator. So the exponent 2 times the exponent 1 is 2, so we get 5 to the 2nd times r to the 2nd times t to the 2nd, and in the denominator we get 8 to the 2nd. Okay, we're getting there. We're a couple of steps away. Now on the left, apply the outer exponent 3. The factor 2 has an exponent of 1, even though we normally don't write the exponent 1 when we have the exponent 1. So we're going to multiply the outer exponent 3 times each of those 4 exponents. So we'll get 2 to the 3rd times r to the 24th times t to the 21st divided by 3 to the 3rd. And we can simplify this expression on the right. 5 to the second is 25, and then r to the second times t to the second. And in the denominator, we have 64. Okay, we can start to simplify. We'll do a few things to simplify here. 2 to the third is 8. And I'm going to bring this numerical factor 25 so that it's next to 8, because we're just multiplying two fractions. And we can simplify r to the 24th times r to the second. So that's r to the 26th. And then also t to the 21st times t to the second is t to the 23rd. So that takes care of everything in the numerator so far. And in the denominator, 3 to the third is 27 times 64. Okay, so just a little bit left. We can cancel common factors. 8 goes into 8 once, and it goes into 64 8 times. So we can deal with that right now. 8 goes into 8 once, and into 64 8 times. So the numerator, 25 r to the 26th times t to the 23rd. The numerator is as simplified as it can be. And the denominator, 27 times 8, 160 plus 56 is 216. Okay, so that's as simplified as we can get. 25 over 216 can't be simplified any further. So. All right, we'll get a few fairly simple ones for a while, and then we'll get progressively more challenging ones. Simplify the following. We have the rational expression x over 3 raised to the negative 4. So we just write the reciprocal of x over 3, which is 3 over x, and change the exponent to positive 4. So think of 3 as 3 to the first, 3 with an exponent 1. Think of x as x to the first. And then we multiply the outer exponent times each of the exponents on the factors on the inside. So we get 3 to the fourth divided by x to the fourth. And 3 to the fourth is 81 divided by x to the fourth. That's as far as we can simplify that. The next one, 10 to the negative 2. That's 1 divided by 10 to the positive 2. And 10 to the second, 10 times 10 is 100. So that simplifies to 1/100th. The next one, in parentheses, we have 3 times x squared y, and that is entire expression is raised to the negative 3. So we write the reciprocal of 3x squared y. The reciprocal is 1 over 3x squared y. And then we change the outer exponent to positive 3. Okay, so this number 1 in the numerator, you can write an exponent 1 for it if you want. You don't have to. But just to remind you what we're going to do next, we're going to multiply the outer exponent 3 times each of the exponents on those terms. 3 is 3 to the first, x to the second has an exponent of 2, y to the first has an exponent of 1. So we get 1 to the third, because 3 times 1 is 3, and then divided by 3 to the third, x to the 3 times 2 is 6 times y to the third. 1 to the third is just 1 times 1 times 1, which is 1. 3 to the third is 3 times 3 times 3, or 27. And so our simplified answer, 1 divided by 27, x to the sixth, y to the third. Okay, the next one, the negative of 1/5 to the negative 2. So on this one, we do the exponentiation first, and then the last thing we do is apply the negative symbol. So we're taking the negative of 1/5 to the negative 2. But 1/5 to the negative 2 is 5 over 1 to the positive 2. And 5 over 1 is just 5. So I'll throw in that extra step. This is the negative of 5 to the second. And we evaluate the exponent and then apply the negative, so we get negative 25. The next one is pretty simple. K to the sixth raised to the 10th. So here we just multiply the outer exponent times the inner exponent, k to the 6 times 10, or k to the 60th. Okay, the next one, y to the third to the 7th times y to the 4th to the 6th. So we'll evaluate the exponents first, and then afterwards multiply the results. So y to the third to the 7th is y to the 7 times 3, or y to the 21st. And y to the 4th to the 6th is y to the 6 times 4, or y to the 24th. And then y to the 21st times y to the 24th is y to the 45th, because we're adding the exponents. So we get y to the 45th. Okay, this next example, I'll show an alternative, or something that you might want to do in a case like this. So we have a quotient. That means there's a division bar involved. And in the numerator, we have an expression raised to a negative exponent. So we have u to the fourth, v to the third, which is raised to the exponent -3. So what we can do is we can write in the numerator u to the fourth, v to the third to the +3. The other expressions already have positive exponents, so they're not going to move. But we can start simplifying those. In the numerator, we have this. We have -3 times u times v to the fifth, all raised to the exponent 4. So we can apply the outer exponent. So here, we're going to raise the number -3 to the fourth times u to the 4 times 1 is u to the fourth times v to the 20th. Okay, so this was the result. This u to the fourth, v to the third, all to the third was the result of moving this to the denominator and changing the exponent to +3. But we also have 6u to the second v to the fifth. So let's go ahead and work on that part. We have the number 6 to the fifth times u to the 5 times 2, or u to the 10th, times v to the fifth, because 5 times 1 is 5. Okay, so let's do a little bit of expanding, and then we'll work on simplifying the variable parts. So in the numerator, -3 to the fourth, so that's -3 times -3 times -3 times -3. That turns out to be +81. So I'll just write 81 u to the fourth, v to the 20th. And then in the denominator, this part, u to the fourth, v to the third, all to the third, we're going to get u to the 12th, because the exponent 3 times the exponent 4 is 12, times v to the 9th. And let's see, 6 to the 5th, well, I'll work on that a little bit later. I know that it's 6 to the third times 6 to the second. So I know that that's 216 times 36. So I'll get that worked out in a minute. And then u to the 10th times v to the 5th. Okay, so I'm going to think of 81, since I don't have a high-powered calculator here. I'm going to think of 81 as 9 times 9. I'll explain why in a minute. And in the denominator, I'm going to move the coefficient or the numerical factors to the left. And I'm going to rewrite 216 as 6 times 36. So I'll have 6 times 36 times 36. And we can start simplifying the variable parts. Well, let's see. In the numerator, I'll write u to the 4th times v to the 20th. We'll simplify the variable parts in the denominator. In the denominator, we have u to the 12th times u to the 10th. So that's u to the 22nd. And then v to the 9th times v to the 5th is v to the 14th. Okay, so we know that 9 goes into 36 4 times. So I'm going to reduce that part. And this 9 goes into that 36 4 times also. And now we're ready to write the simplified form. So in the numerator, we just have a numerical coefficient of 1 times 1 times u to the 4th times v to the 20th. And in the denominator, we have 6 times 4, which is 24. 24 times 4 is 96. So we have a numerical coefficient of 1 in the numerator and 96 in the denominator. And then what's u to the 4th divided by u to the 22nd? It's u to the 18th in the denominator, right? U to the 4th divided by u to the 22nd is u to the 18th in the denominator. And v to the 20th divided by v to the 14th. That's v to the 6th in the numerator. So normally when the coefficient is 1, we don't write it. So I'll just write it as v to the 6th divided by 96 u to the 18th. Okay, so even though these expressions that we are simplifying are more complicated, we're just applying the basic properties along the way. We just have multiple properties to apply. Okay, let's move on to the next page. Okay, this one, in the numerator, we have the term negative 2x to the negative 2 raised to the power 4 times the term 3x to the 4th raised to the power 2. And then in the denominator, negative 6x to the 3rd raised to the power 2. Okay, so this time, for each of those terms that have outer exponents, well, all 3 of those terms, 2 in the numerator and 1 in the denominator, have an outer exponent. So I'm going to apply each of those outer exponents first. So this term, negative 2x to the negative 2, if that's raised to the power 4, we're going to get the number negative 2 raised to the 4th. And then times x to the 4 times negative 2 is x to the negative 8. And then we're multiplying that by 3x to the 4th, which is raised to the power 2. So this is times 3 to the 2nd times x to the positive 8. And then same sort of thing in the denominator. Negative 6x to the 3rd to the 2nd. We have the number negative 6 to the positive 2 times x to the 6th, because the exponent 2 times the exponent 3 is 6. The number negative 2 to the 4th, negative 2 times negative 2 times negative 2 times negative 2 is positive 16. And 3 to the 2nd is 9, so I'm going to move the numerical factor farther to the left. And we can simplify x to the negative 8 times x to the 8th. That's x to the negative 8 plus 8, or x to the 0. And then in the denominator, the number negative 6 squared is 36 times x to the 6th. X to the 0 is 1. We're assuming x is non-zero. So x to the 0 is 1. And you can simplify the numerical parts in a couple of ways. 16 times 9 is 144, and 144 divided by 36 is 4. Or we can cancel common factors first. 9 goes into 9 once and into 36 4 times. And then 16 divided by 4 is 4. So we just are left with 4 divided by x to the 6th. Okay, the next one. We have a rational expression raised to the exponent negative 3, and we're multiplying that by another rational expression raised to the power of 2. So I'm going to simplify what's inside each set of parentheses, and then afterwards apply the outer exponents. So we have a rational expression raised to the negative 3. We're going to simplify the rational expression first. And then we're multiplying that by another, whoops, I don't want to do that yet. We're going to simplify that rational expression and then afterwards raise it to the power 2. Okay, so starting on the left, 3 divided by 2, that doesn't simplify any further, so 3 over 2. And then when we focus on the variable a to the negative 4 divided by a to the 3rd, what does that simplify to?
A to the negative 1.
A to the negative 7 in the numerator, or a to the positive 7 in the denominator, which is what we want, right? So a to the negative 4 divided by a to the 3rd is a to the 7th in the denominator. And then b to the 2nd divided by b is just b to the 1st, or b in the numerator. Then in the other set of parentheses, 6a to the 2nd, b to the 3rd over 8a, b to the 5th. 6 over 8, what does that simplify to?
3 over 4.
Yeah, 3 over 4. So we have a factor of 3 in the numerator and a factor of 4 in the denominator. And then a to the 2nd divided by a to the 1st is a in the numerator. And b to the 3rd divided by b to the 5th is b to the 2nd in the denominator. Okay, now starting on the left, since we have a fraction raised to a negative exponent, we reciprocate the fraction and change the exponent to positive 3. So we have 2a to the 7th over 3b with a positive exponent 3. And we can apply it for this term on the right, we can apply the outer exponent 2. So we get 3 to the second times a to the second over 4 to the second times b to the 4th, because we're multiplying exponents. 2 times 2 is 4. Okay, then on the left, apply the outer exponent 3. So we're going to get 2 to the 3rd times a to the 21st, because 3 times 7 is 21. In the denominator, we'll get 3 to the 3rd times b to the 3rd. And we can simplify a little bit over here. 3 to the second is 9, so we get 9a to the 2nd. And then 4 to the 2nd is 16 times b to the 4th. So we're almost done with this one. 2 to the 3rd is 8. I'll move the numerical factor 9 next to 8, so 8 times 9. And we can simplify a to the 21st times a to the 2nd to get a to the 23rd. And in the denominator, 3 to the 3rd is 27 times 16. And then we simplify b to the 3rd times b to the 4th to get b to the 7th. And rather than multiplying the numerical factors and then writing the fraction in lowest terms, we can find common factors that cancel beforehand. So 8 goes into 8 once and into 16 twice. So 8 goes into 8 once and into 16 twice. 9 goes into 9 once and into 27 3 times. So now we can write the final result. In the numerator, 1 times 1 times a to the 23rd is just a to the 23rd. And in the denominator, 3 times 2 times b to the 7th is 6 times b to the 7th. So that's the simplified expression on that one. So let's see how far we can get on the next one. Okay, so let's simplify on the inside of each set of parentheses first, and then deal with the outer exponents later. So inside the set of parentheses on the left, 2 divided by 3 cannot be written in lower terms. E to the 7th divided by e to the 2nd is e to the 5th in the numerator, e to the 7 minus 2. H to the 4th divided by h to the 9th is h to the positive 5 in the denominator, because it's h to the 9 minus 4 in the denominator. And that's all raised to the exponent -1. In the other set of parentheses, 4 divided by 3 cannot be simplified further. E to the 2nd divided by e is e in the numerator. H to the 3rd divided by h to the 5th is h to the 2nd in the denominator. Okay, this expression on the left has an exponent of -1, so we'll write the reciprocal, which is 3h to the 5th over 2e to the 5th, and the outer exponent is 1. And for this expression on the right, we can apply the outer exponent 2. So we'll get 4 to the 2nd times e to the 2nd in the numerator, and in the denominator, 3 to the 2nd times h to the 4th. When we raise something to the first power, nothing changes, so we can go ahead and multiply 3 times 4 to the 2nd, or 3 times 16, and then times h to the 5th times e to the 2nd. And in the denominator, 2 times 3 to the 2nd is 2 times 9, times e to the 5th times h to the 4th. Okay, so we can simplify. 3 goes into 3 once and into 9 3 times. 2 goes into 2 once and into 16 8 times. So 1 times 8 divided by 1 times 3 is 8/3. H to the 5th divided by h to the 4th is h in the numerator. And in the denominator, since we have e to the 2nd divided by e to the 5th, we have e to the 3rd in the denominator. So that is our simplified result. Okay, we're about out of time. The two that we didn't finish are easier. All you have to do is apply the product rule and then negative exponents too. Okay, so we're out of time for today.
means I'm first.
Pardon?
Guess that means I'm here first.